Now we reach one of the key components of the project execution, which is report generation and quantity takeoff. In other words, extracting outputs from the model to support decision making. We have learned that BIM is not just for visualization. Behind the model lies a vast amount of data that supports informed decisions. In fact, the main purpose of the creating BIM model is to obtain accurate and we can say usable information. Information that can be used for decision making, cost control, and more precise project scheduling. This is where reporting and quantity takeoff become critically important. Quantity takeoff refers to the accurate extraction of volumes, areas, length, and counts of elements directly from the model. It allows us to understand exactly what exists in the project, how much of each item is required, and where each element is located. For example, we can determine how many cubic, for example, meters of concrete are required, how many square meters of tiles or paint are needed, or how many doors must be ordered, including their dimensions and types. All of this information is extracted directly from the BIM model. In traditional projects, quantity surveyors perform this task using 2D drawings. In BIM, however, the 3D model itself contains the data as long as the model is created correctly, completely, and according to standards. The software can automatically calculate all quantities. But why is this important? This process is crucial because three key project decisions depend directly on the accuracy of these data. So, cost estimation. Number one. In every project, the first question the client asks is, how much is this project going to cost me? If material quantities, concrete volumes, or the number of the elements are inaccurate, the cost estimate will be fundamentally flawed. For example, imagine the slab thickness or column dimensions in the model are slightly incorrect. At first glance, the difference may seem minor, but in real project it can result in millions of dollars of discrepancy in the cost estimate. Accurate quantity takeoff ensures that cost estimates are realistic and allows contractors to submit rational and data-driven financial proposals rather than estimates based on assumptions or guesswork. Number two, time planning and scheduling. When you know exactly how much concrete, steel, or other materials are required, you can create a more realistic and precise construction schedule. For instance, if we know that constructing the foundation requires 200 cubic meters of concrete and the execution capacity is 50 cubic meters per day, we can easily estimate the exact duration of that construction phase. It means quantity takeoff directly connects the fourth dimension of the BIM, time management. The 3D model integrates with the project schedule, showing which parts of the project will be executed at each stage. So the third case actually is controlling of the development of a project. That means progress tracking. At this stage, we enter the execution phase. For instance, if the project has 500 columns in total and 300 have already been constructed, knowing these numbers allows you to calculate the actual percentage of the progress. Furthermore, if the BIM model is kept up to date, you can quickly understand the project's physical and financial status at any moment. This is why quantity takeoff is not just an initial step for cost estimation. It is a tool for financial time and execution control throughout the project lifecycle, from design and construction to maintenance. Decisions are always guided by this data. So now let's see who is responsible for quantity takeoff. In BIM projects, quantity extraction is a team effort, but each role has clearly defined responsibilities. So first of all, modeling team. Everything starts with the modeling team. If the data entered into the model is incomplete, incorrect, or non-standard, the quantity takeoff output will be unreliable. For example, if a modeler enters incorrect wall materials or slab thickness, I don't know, the software cannot calculate accurate volumes of bricks, concrete, or plaster. The modeling team is responsible for producing accurate data according to the BEP and defined LOD, which forms the basis for all quantity calculations. Number two is BIM coordinator. Once the models are prepared, the BIM coordinator collects them and uses software like Revit Schedule or Navisworks quantification to extract data from the models. It's not just about extraction. The coordinator must ensure that models have no clashes and no elements are double counted. Coordinators clean and standardize the data, preparing it for analysis. Now, let's go for number three, quantity surveyor. The quantity surveyor is a key role in the quantity takeoff process. Actually, they receive verified clash-free data from the BIM coordinator and start analyzing it from financial, economic, and managerial perspectives. Their task is not just to record 10 tons of steel or 200 cubic meters of concrete. They convert the raw model data into actual project costs. For example, cost per cubic meter of concrete, transportation costs, and whether it aligns with the project budget. QS typically works with financial software like Excel or Candy to transform raw model data into accurate and presentable financial reports. These reports serve as the basis for decision making by the client, financial team, or contractor, including program payments, procurement, evaluation, and cost control. Depending on the contract type, the QS role may vary. In some projects, the QS is part of the consultant team, controlling costs on behalf of the client. In large, multi-contractor projects, the client often hires an independent QS with no ties to consultant or, contractors. This QS collects reports from various teams, validates them, and submits a neutral final report. In such cases, the QS works closely with the client's BIM manager to ensure that the quantity data and costs align with BEP standards and AIR requirements. So, role of the BIM manager. So now let's go for role of BIM manager. The BIM manager oversees data reliability. They ensure that reports are generated based on accurate models, structured properly, and following standards. For example, they verify that cost parameters are defined in the model and reports comply with the BEP and client requirements. In short, the BIM manager guarantees the trustworthiness of the model's data. If the model is incorrect, the QS will analyze it incorrectly, and the client will make decisions based on wrong information. Therefore, the final control of the data accuracy and report validity is always under the supervision of the BIM manager. So, who receives these reports? Each report has a specific purpose and a different audience. For example, for the client, reports for the client are usually concise, clear, and easy to understand without complex technical modifications. The goal is for the client to quickly grasp the project's current status and resource consumption. For example, this month, 85% of the concrete structure has been completed and 15% is still under construction, or steel consumption is 3% lower than the initial estimate. Clients use these reports for financial decisions, payments, and progress evaluation. The second one, for the financial and project control team. Reports for the financial or project control team are more detailed and numerical. For example, tables of concrete quantities per floor, flooring area, or required material volumes for the upcoming month. These data help with accurate budgeting schedule payments, and preventing over or under purchasing of materials. So the final stage for the design team or execution contractors. At this stage, reports become fully technical. For example, they may include a detailed list of walls for each floor specifying the material type, thickness, paint surface, or brick type. These reports are used for material ordering, coordination among contractors, checking and aligning construction with the model. This part of reporting ensures that model is accurate and constructible. When reports are precise, rework is minimized because incorrect quantities do not reach to the site. Material ordering is more accurate, preventing shortages or actually surplus. And during construction, actual consumption can be compared with the model. Ultimately, at project handover, the final model LOD 500 serves as a real database of quantities, costs, and project progress. Therefore, quantity takeoff in BIM is not just a numerical table. It is an intelligent system that shows the project's status in terms of cost, time, and resources. The modeler creates the data. The BIM coordinator extracts it. The BIM manager ensures everything is accurate, transparent, and standard compliant. And finally, the quantity surveyor, or QS, analyzes that. So with the collaboration, the project does not rely on guesswork. Instead, decisions are based on numbers, analysis, and trust.